India currently stands as the most populous nation on Earth. With approximately 1.47 billion people living within its borders, the country has officially surpassed China in total population. What makes this even more remarkable is that roughly 18% of the entire global population resides in India, yet the country occupies only about 2% of the total global landmass. This enormous gap between population share and land share is precisely why many people describe India as overpopulated. There are many commonly cited explanations for this demographic reality. Some people point to a historical lack of widespread modern education. Others blame systemic poverty. It is frequently argued in casual discussions that economically disadvantaged families tend to have more children because they see each child as a potential earner who can contribute to the household income. Additionally, certain northern states such as Uttar Pradesh and Bihar are often singled out for their enormous contribution to the national population. Together, these two states account for roughly 370 million people, a combined figure that exceeds the total population of the United States or Indonesia. If they were separated as an independent nation, they would immediately become the third most populous country in the world. However, blaming specific communities or regions for population growth misses the deeper truth entirely. The real driving force behind India's massive population lies not in human choices alone, but in something far more ancient and powerful: geography itself. India's enormous population is not a recent phenomenon. 1,000 years ago, 2,000 years ago, and even 4,000 years ago, this land supported an exceptionally large share of the global population. According to the detailed economic research of the renowned British economist Angus Maddison, from the year 1 AD through the year 1000 AD, India consistently housed approximately 30% of the world's total population. That means during an entire millennium of human history, roughly every third person alive on Earth was living in the Indian subcontinent. Today, approximately every sixth person in the world is Indian, which means that as a proportion of global population, India's share has actually decreased over the centuries rather than increased. So what caused this extraordinary historical concentration of humanity? The answer, in a single word, is geography. When people discuss population dynamics today, they tend to focus on modern socioeconomic factors such as education levels, literacy rates, poverty, and healthcare access. While these factors are undeniably important in the modern context, they overlook the single most influential historical force shaping where and how many people live: the physical landscape itself. Throughout history, regions blessed with flowing rivers and highly fertile agricultural land have served as the foundations for the largest human civilizations. The oldest known civilizations in the world were all built directly alongside major rivers. Ancient Mesopotamia thrived on the banks of the Tigris and Euphrates rivers. Egyptian civilization was inseparable from the Nile. The Yellow River gave rise to ancient Chinese civilization, and the remarkable Indus Valley Civilization blossomed along the banks of the Indus River. In every case, fertile land made farming easier. Farming guaranteed a stable food supply, and a stable food supply allowed populations to grow and thrive. India possesses something geographically extraordinary: the world's largest continuous stretch of highly fertile alluvial plain. Known as the Indo-Gangetic Plain, this massive geographic feature stretches across northern India from Sindh in modern-day Pakistan through Punjab, Haryana, Delhi, Uttar Pradesh, and Bihar, ultimately reaching the Sundarbans Delta in Bangladesh. Covering more than 700,000 square kilometers, this single geographic strip currently supports roughly 11% of the entire world's population. The formation of this plain is tied directly to the existence of the Himalayas. Approximately 50 million years ago, the Indian tectonic plate broke away from the ancient supercontinent of Gondwana and collided with the Eurasian plate. This collision pushed the Earth's crust upward, forming the Himalayan mountain range. At the base of these newly formed mountains, a massive geological depression formed. Over millions of years, rivers flowing from the Himalayas and older geological formations filled this depression with enormous quantities of eroded soil, crushed rock, and organic matter. The result was an incredibly deep layer of nutrient-rich soil known as alluvium, a type of soil ideally suited for agriculture. The Himalayas also gave rise to a remarkably dense network of rivers. The Indo-Gangetic Plain is named after two of its most important waterways, the Indus and the Ganga, but it is sustained by many more. The Ganga flows southward, the Brahmaputra flows eastward, and the Indus flows westward through Kashmir toward Pakistan. Nowhere else on Earth will you find so many massive rivers concentrated in such a relatively compact geographic area. These permanently flowing rivers, fed by melting glacial snow, ensured a reliable water supply for agriculture across thousands of years. According to historian Tim Dyson, the Indus Valley Civilization at its peak supported a population of 4 to 6 million people, making it more populous than any other civilization on Earth at that time. Ancient China's Yellow River Civilization, by comparison, supported an estimated 3.5 million people. Even 4,000 years ago, this Indian region was already the most densely populated area in the world, strictly because of its fertile plains and reliable rivers. This geographic pattern repeats across the globe. China's North China Plain, nourished by the Yellow River, the Huai River, and the Hai River, currently supports roughly 400 million people. The Netherlands and Belgium, two of the most densely populated countries in Europe, sit on the rich alluvial deltas of the Rhine, Meuse, and Scheldt rivers. The Netherlands has a population density of 531 people per square kilometer, actually higher than India's average density of 484. Despite being roughly half the size of a single Indian state, the Netherlands is the world's second-largest agricultural exporter by value, a testament to the extraordinary productivity of fertile alluvial land. Japan offers another fascinating example. Though roughly 73% of its landmass consists of rugged, unfarmable mountains, its population exceeds 120 million. The reason is that the surrounding ocean historically provided an abundance of nutritious seafood, enabling the island nation to sustain a large population even without vast farmland. If other regions also have fertile land, why has India's population historically been even larger? The answer lies in two critical differences: scale and water supply. The Indo-Gangetic Plain is simply enormous, covering over 700,000 square kilometers. The North China Plain, by comparison, spans roughly 400,000 square kilometers. Egypt's Nile Valley occupies just 33,000 square kilometers, a thin green strip surrounded on both sides by inhospitable desert. This is why approximately 95% of Egypt's 110 million people live within just 20 kilometers of the Nile riverbanks. Beyond sheer size, the Indo-Gangetic Plain benefits from a unique combination of water sources. Egypt depends entirely on the single Nile River and receives almost no rainfall. The North China Plain similarly lacks a dedicated rainy season. But in India, the Himalayas provide not only multiple permanently flowing rivers, but also the monsoon season. The towering mountains act as an impenetrable physical barrier, trapping moisture-laden southwest winds and forcing them to release heavy, consistent rainfall across the plains. Additionally, these same mountains block freezing cold air from Central Asia during winter, keeping the plains warm enough for year-round agriculture. This triple geographic advantage, warm climate, fertile soil, and monsoon rains, means that food crops in the Indo-Gangetic Plain can be harvested 2 to 3 times per year. This is extremely rare elsewhere in the world. The fertile plains of Western Europe become too cold in winter. China's northern plains lack a proper monsoon. But in India, this remarkable climate has sustained multiple annual harvests for thousands of years. Around 304 BC, when the Greek diplomat Megasthenes visited the court of Emperor Chandragupta Maurya, he was astonished to observe that India produced 2 major food crops per year. In his detailed account titled Indica, he wrote that widespread food shortage was virtually unknown in ancient India, precisely because the dual crop system provided a safety net. If one seasonal crop failed, the other could still feed the population. Historically, India's population consistently exceeded China's. In the year 1 AD, India housed 32.5% of the global population compared to China's 25.8%. In 1000 AD, the figures were 28% and 22% respectively. Even as recently as 1700, India held 27.3% against China's 22.9%. The reversal came during the colonial period. Under colonial rule, India experienced approximately 25 major preventable famines between 1770 and 1947. An estimated 30 to 35 million people perished from starvation during this period. To put this in perspective, approximately 8.5 million people were lost during the entirety of World War I. The colonial-era death toll was roughly 4 times greater. These devastating famines were not caused by geography or nature. They resulted from exploitative economic policies that diverted essential food resources away from the local population. The Great Bengal Famine of 1770 wiped out an estimated 10 million people, roughly one-third of the Bengal region's entire population. The famines of 1876 to 1878 took another 7 to 8 million lives. After independence in 1947, the artificial suppression of India's natural agricultural potential ended. Population growth resumed rapidly. Between 1947 and 1981, India's population doubled. The transformative Green Revolution of the 1960s dramatically increased wheat production to the point where, by 1968, India literally ran out of storage space for the harvested grain. Today, India's population is naturally stabilizing. The current total fertility rate stands at approximately 1.9, which is already below the demographic replacement level of 2.1. This means that within a few decades, India's population will begin to decline. According to United Nations projections, the population will peak around 2060 and then steadily decrease. In 31 out of 36 states and union territories, the fertility rate is already at or below replacement level. Several southern and western states have fertility rates comparable to those of developed European nations, hovering between 1.3 and 1.5. The accurate response to anyone who asks why India is so heavily populated is not that India is overpopulated, but rather that India is extraordinarily geographically blessed. It possesses the world's largest continuous stretch of fertile alluvial land, the world's highest mountain range providing permanent rivers and monsoon rains, and a climate that enables multiple harvests per year. However, these very geographic blessings now face serious environmental threats. Between 2010 and 2019, Himalayan glaciers melted approximately 65% faster compared to the previous decade. Crucial winter snowfall has fallen dangerously below historical averages. Snow persistence in the Himalayas is at its lowest recorded level in over 2 decades. Scientific projections warn that by the end of this century, 1/3 to 1/2 of the Himalayan snow cap could irreversibly disappear. As glaciers shrink, the rivers they feed will eventually carry less water. Monsoon patterns are becoming increasingly unpredictable, with some years bringing destructive flooding and others bringing severe drought. In 2022 alone, extreme weather events destroyed crops across 5 million acres of farmland. Underground water reserves beneath the Indo-Gangetic Plain are also declining rapidly due to unsustainable agricultural practices. If these environmental challenges are not addressed with urgency, the geographic blessing that sustained Indian civilization for millennia could transform into an unprecedented crisis for hundreds of millions of people. Protecting rivers from degradation, preserving forests, and reducing dependence on fossil fuels are not optional measures. They are essential for safeguarding the very foundation upon which this civilization was built. India's remarkable population story is ultimately a story of geography, of rivers, mountains, fertile soil, and monsoon winds working together across millennia to create one of the most extraordinary cradles of human life on Earth. Understanding this truth is the first step toward ensuring that this natural wonder endures for generations to come.